go. Hi, everybody. Glad some of you can make it for the live stream. It's always appreciated when you can do that. I like the interaction. Hope you're doing well. If you're watching the video later in the week, I hope you've had a good week. We are starting week 6, so we're getting deep into the semester now, which feels pretty good. Yeah, so I'm going to start this week by showing off some of the work that I just selected a few examples of the work that people are doing on their labs, just so you can see what your classmates are doing. So I'm going to go right now and create a Repl for it, and then I'll paste the sample programs in and run them, and just kind of make a comment or two about what I saw in these examples that I thought was kind of cool. So let me do that real quick. Go demos. Okay, so there are plenty of others that were good. I just picked a small number of them that I thought were just kind of cool for one reason or another. So this one has pretty fancy output as an example, so I quite enjoyed that. Put that back. That's not when I was born. See how the prompt is really cool with the little squiggles, the tildes, and the arrow, and the extra spaces to kind of group together the sections of output. It just looks really good. And the prompt including this should be 4 digits. I've been going, by the way, with this 3 out of 4, which should give me 75%. Very nice touch with the percent sign in the output, which was a requirement if you read the documentation. So I didn't keep the person's name just to keep them anonymous, but you'll no doubt you'll recognize your work if you're watching. So nice one. That was a very nice one. I've got 4 of them here, so I'll just quickly put those in and run them. This one's clearing the screen, which is pretty sweet. Let's go. I hope they don't mind. I'm going to take their code that clears the screen and share it with people, and maybe use it. So I'm going to put it in the agenda here. I don't know why I did that. So this line of code right here, it's got a bunch of funky symbols on it, and if you have trouble transcribing it, you could always go out in the piazza and we could get this shared out with people. But anyway, there that I just added to the agenda is the code that this person is using to clear the screen. It's really weird looking, I know, but it is a very effective way of clearing the screen, which works. And look how nice it looks with all the trash gone off the screen. And they also have this little touch with the press enter to continue, which is cool. So between sections, you see, 3 and 4, and there's 75%. So probably I took a few points off for not having the percent sign in here, but overall though I liked the way this one looked and it had the nice clearing the screen touch and stuff in it. So quite cool. This person's developed their own kind of nice style for doing prompts with the little dash and then the space, and then so that looks pretty smart, I think. And then the perfect, your average is 75% with 2 places past the decimal, the percent sign showing on the screen. Also a very nice piece of work. And then one last one just so you can see it. This one has the cool prompts where it tells you kind of the format that's being looked for, and then also the perfect output on the average, which is exactly as described in the assignment. So good work, you guys, on that. Probably you'll recognize your own work, but lots of you had things that were similar to that. So you guys did really good. I thought that I thought that this lab was kind of getting into something much more difficult, but pretty much everybody nailed this lab, just like you have all the others. Oh, nice. So Karina can be here because the class got canceled. Well, welcome to the live stream. I'm really glad that you can be here. I don't want your other class to get canceled a lot, but it'd be, hopefully maybe this isn't the last time and something else will let you, once in a blue moon stop in and say hi. So welcome to the live stream, Karina. Okay. So anyway, that was some cool labs. Just wanted to show you that. Printing the percent sign on the screen. I'll just put that one here. So it looks like this with whatever other stuff you got. But the way you cause the percent sign just a single one to print is you put a double one in there. You can reason your way to understanding why this would be this way, because the single percent has a special meaning to go in a printf. It's usually meant to set up a placeholder for a formatting verb, like a string formatting verb or an integer or a float or whatever. So because Go is looking for the formatting verb, it gets confused when it sees a single percentage sign and nothing else in this printf. So to get that symbol to print, you put all the other stuff that you would want in there, and then you put the double percentages. I took off a couple to a few points. I can't remember, maybe a couple of points if you didn't get the percent sign in there, because I assume that people didn't put it in there because they didn't know how to put it in there. So I wanted to call your attention to it. We did it last week in lab, or maybe a couple weeks ago, but we've done it recently when we showed the output of a mod operation. So anyway, add that to the agenda. And yeah, so let's go into the new stuff. First, I will call your attention to what's going on more generally. Let me try to make this bigger. There, that's what I want. So the second individual project seems like a long way away, but October 23rd will come sooner than you think. So the time to get your first reading of that project is soon. And then starting next week, probably, I will start to point you in the direction of the things that you can do to solve that project. So have a look at it. It doesn't mean you have to start it. And if you find things you don't know how to do in the second individual project, well, that's okay, because now you know what's coming in the next few weeks leading up to that project being due. So get it on your schedule, get it on your radar, and start visiting the project at least to read it on a regular basis and decide what you feel like you're ready and not ready to do just yet. Okay, week 6. So let's walk through the module, and then we'll look at code examples of these things. Okay, so we'll repeat some of the stuff we did last week, which is talking about how do you set up a function in the Go language. We're going to add a new element this week, which we call a return value. And the idea of return values is that it lets functions talk back and forth to each other. This is a very difficult concept to get comfortable with. All of us, myself, every computer science teacher I've ever known, every programmer I've ever known, all of us, it takes some time to get comfortable with functions and how they work. So parameters and how they work, return types, return values and how they work. It takes time to get accustomed to it. So just be patient with yourself. You will be able to solve problems if you read and follow the directions carefully, and then hopefully over time you will begin to understand exactly kind of what the code means, what it is doing, what it is achieving. But initially these are hard concepts, so don't worry about it if you look at them and you think these are hard concepts. They are, and they're hard for all of us. Okay, so we're going to implement functions. We did this last week that accept parameters. What we're adding that's different this week is that we will have functions return things. which is a difficult concept. And then we will invoke functions and use invoking or calling functions to assemble a program run. And then we're adding something new that is sort of an automated evaluation tool. It's commonly used by programmers these days, so I want to expose you to the concept. It's called unit testing. This week, your lab will actually have a unit test in it, so I'll show you before we close out tonight how to use a unit test. We're going to look at a unit test, and the code inside of it may look a little bit intimidating, but I'll tell you before we ever get that far that you do not have to create unit tests in our class. I will create them for you. Your job is to pass them. And the way you pass a unit test is that you write code that the unit test tests or evaluates. So your job is to write code and then let the unit test do its work and tell you whether or not you passed. But I'll write a few small examples to show you how I build them. And then I'll show you some where they fail and some where they pass, so you know what to be on the lookout for. It's a very cool feature of the Go language that it's more or less built right in. Okay, just moving past those things. Okay, so the lab, let me take it back down. So there's some extra content in here, and we'll see when I go into Repl if I have this problem. But in the past, some people have had a problem with one of the steps in setting up their lab this week in Repl. So if I have that problem, I will follow my own, instructions to solve that problem. If I don't, I won't be able to do this, but just know that there's this whole section that if you struggle with one part of the setup of your lab this week, I've got a little sort of graphical guide for getting around that problem. We'll see if it happens. If it doesn't happen to me, it probably won't happen to you. And then this week we're going to have two files inside of our Repl. So normally we just have main.go in there. This week we're going to have a file called main_test.go. That's the unit test. I'm going to create one from scratch and show you how they work. Yeah, okay, so that's the lab. So Piazza so our discussion this week will be related to this unit test idea. So I'll just kind of spoil it a little bit, but the unit testing technique that you will experience in your lab this week is part of a sort of larger strategy for programmers called test-driven development. It doesn't really matter if we dig that deep into it. You're going to get to do some research and discuss test-driven development in Piazza this week. But the spoiler is you're doing it. You are doing TDD or test-driven development this week. I wrote a test and it will drive your development of your code. And then the normal stuff for this week, so homework lab discussion, and then start getting the second project on your radar. Sooner than later is a time to read it. I'll probably go through and read it next week on the live stream / lecture video, but you might get ahead of the game and read it for yourself. Okay, let's go into Repl. Where did I put Repl? Here. And try this unit testing thing. Let me get myself a new Repl, a Go Repl. I will call it week 6. I don't know. Example. We also, of course, have to do a new thing with functions, and then we'll kind of put it all together in a unit test and a little program. So let's do some reviewing of functions first. So what we know right now, well, one thing we know is that main is a function, and it has all of the pieces that make up a function in the Go language. So it has this Go language keyword, func, which is how you define or set up to implement a function. And every function in Go has a name. Well, that's not entirely true, but our functions will all have names. This function is called main, and what's special about the main function is that every application in Go has one. This main function is where the system knows to go to begin the process of running a program. So to have an application in Go, you have to have a func main in it. So we will always in our class have a func main somewhere in our project that represents the spot where the program begins its execution. It has this parentheses, that's the parameter list. When the parentheses are empty, we say that's an empty parameter list. And then the block marked by the opening and closing curly braces, the block of code which contains the work that the function does. Okay, so let's make a new one. Func, I'll say greet. So I write this keyword func. Notice, by the way, I'm completely outside of and separate from every other function. So here's func main. Func main parameter list. The block is completely self-contained, and then this func greet is going to be also completely self-contained. So I use the Go keyword func. That's how you define or begin to implement a function in Go. I'm going to call it greet. You'll see me in a lot of the labs use capital letters here. That's not going to matter tons for us, but I think I might start getting in the habit to match what I'm doing in the labs. So let's start capitalizing our functions, and then we have to leave main alone. So don't capitalize main or it won't work like you think. But for our own functions, let's start capitalizing them. Empty parameter list. So the parameter list has to be there when you implement a function, even if it's empty. There's nothing in between the parentheses. And then the block. Okay. So let's make this one do something very simple like I am 100% happy to see you. And a new line at the end. So there's an example of what will become a single percentage sign in the output. Okay, so here's my function. Func, to set it up, I chose the name greet. I'm going to start capitalizing all my functions, which is one way to kind of quickly scan through code and find your functions, because the things that are capitalized will be your functions, at least for a while. Parameter list, even if it's empty, it has to be there. And then my block, and then inside of my block I put what I want this function to do. Okay, I'm going to run it. I don't know if I have anybody. I'll keep asking once or twice a week and see if anyone out there wants to venture and answer. So why did my greeting not print? Nice. So the Dan bar's right. I didn't. So it's invoke, I-N-V-O-K-E, but you are correct. I did not invoke it, or and Keller's got it too. So I didn't call it. And you can use those words interchangeably. So I need to call this function. A function just sitting there doesn't do anything. You have to invoke it or call it, and we use those words interchangeably. And I already know that when the computer starts executing my program, it's going to drop straight into main and do stuff. So the stuff I want to happen is going to be plugged in right here. So let's call this function. The way you call or invoke a function is by its name and with its parameter list, even if it's empty. So this will cause Go to jump basically to the greet function, find its block, execute the stuff in its block, and then what Go will do after that is jump back to where it left off and continue with whatever follows in the program. So in this case, I don't have anything that follows. So it'll print this one thing, and then that will be the end of the program. So good on you guys for getting that in chat, the Dan Bar and Keller. we're on top of that. So there's my greeting. So I implement it and then I invoke it. This is one of the things that's hard about functions for people. This was true for me, I'm sure, but we see this entire thing as just, we see our entire program as one thing. And it's confusing at first to imagine that our program, which we want to think of as a single thing that we created, is actually a collection of multiple things ultimately. So it's becoming a collection of functions. We have the automatically executed function, but then I start to create my own functions. And to get them to execute, I have to somehow plug them into other functions that are being executed, which is a lot to take in. There's a variety of tricks you can use to convince yourself that this is true. For me, it was less being able to explain it to myself in a way that I thought was intelligent, and more that I could figure out how to make it work. So I knew how to make it work when I was learning programming, these functions, a long time before I could tell you why it worked that way. So I was okay with that when I was going through it, and if that is your experience, then I hope you'll be okay with that as well. A few people might sort of quickly just latch on to what's going on here and be able to explain it to themselves. But part of it is just kind of fighting it a little bit until you know how to make it work. So how do I make a function work? Well, I make the function and then I call the function somewhere. It's really only 2 steps, but it's 2 complicated steps because why isn't this just all one thing? But the fact of the matter is, once you get separate functions, then you have separate things, and you have to figure out how to kind of connect them with each other so they will do their job. Let's do one with a parameter. Let's do a Mad Libs one. Mad Libs, if you haven't played it before, it's kind of a kid's game where you get this sheet of paper and it has a little story, and little gaps have been created in the story, and you'll ask your friend, like, what's your favorite food? What's your favorite color? What day is today? How old are you? And then you plug those words into a Mad Lib, and it becomes, and the words don't go in the original story. They just go into some silly story. Like yesterday, I saw 20 lions and we all ate hamburgers together. I don't know. Anyway, I'm going to do a Mad Lib. So that's what this is. It's just a little kind of fun. Enjoy your. So let's do a Mad Libs where we do a color, and we'll do a food, and those will both be strings. So this is a function with 2 parameters. They are both strings. So one of the parameters is a color, the other one is a food. Enjoy your, and then we'll just kind of put the color next to the food, so it'll be like enjoy your green macaroni and cheese, or I don't know, whatever the person says. And then we'll plug in color first, and then food second, and now we have a little Mad Libs. And then we will go invoke it from main. So I have set up my little Mad Libs, and I've put parameters in it. So now I'm going to go into main, and I'm going to set up to collect the information that the function needs, so that I can then send that information to the function and let it do its job. So I'm going to create a var color string here, and I will say .printf, what is your favorite color? And f food. Now I hope this isn't too slow for some of you. The reason I'm typing it out like this is to, in part, to slow myself down and let people kind of see the sequencing kind of be put together in real time. Food. Okay, so if I am to invoke this function madlibs, which is the way I'm going to get it to execute this little joke, I have to have information to give it. So I could, if I wanted to, simply do a madlibs with purple, and as long as I give it 2 strings, it could be whatever I want. So purple, what shouldn't be purple? Say enchiladas. So if I am to invoke or call madlibs, I have to supply it with 2 pieces of information, 2 parameters, each of which is a string. Does technically it have to be in a color and a food? It does not. All Go cares about is it 2 strings? So I could say, you know, one of these kind of... Oh, wait, that's going to look like a curse word. I'm not going to do that. I don't want a curse word showing up. I'm going to say... slow bicycle. So it doesn't have to be a color or a food. Go is not going to check me on that. It just has to be a string and another string. So my job as the programmer is to try to supply the function with information that makes sense. It's telling me it wants a color and a food, so I bet it's going to work out better if I give it a color followed by a food. If I switch those around, by the way, so I'll give it a food followed by a color. I'll say hamburger, green. I'll switch them around to see what happens with that. And then finally, I'm going to do it in the interactive way where I let the user... So notice here I'm being careful with my user. And since I know the function, madlibs wants a color and a food that are strings, well, I'm going to give it that. So I'm going to set up a string variable called color. I'm going to ask the user to tell me what their favorite color is. And then I'm going to grab that information off the keyboard. And then a food. And then when I send that or pass that information to the function, I'm going to pass it in the order that the function tells me those things should be passed. But just for fun, let's see what happens if we reverse the order. Because Go, as I was saying, so let's prove it. Go doesn't care what order they come in. It's going to print them out. It's going to assume that the first one is the color and the second one is the food, even if I accidentally switch them around. So let's run it and see what it does with all of those different bits and pieces. So there's my greeting. Enjoy your slow bicycle. So notice on this first one, it took slow for the color. Slow is the first one. And it took bicycle for the food. Now the second one, purple enchiladas. So it took purple, the first one, as the color. Enchiladas, the second one, is the food. The third one, enjoy your hamburger green. So it took hamburger as the color, green as the food. So the computer has no way of figuring out that you screwed up the order of things. All that the computer can do is check to see if the kind of information and the amount of it matches. So the computer knows it's supposed to be a string and another string, but it has no way of checking what those things actually are in terms of a dictionary or syntax. The first thing's going to be the color, and the second thing's going to be the food. And good luck if you reverse them. So you notice enjoy your hamburger green, and then I will say, I don't know, color red. Favorite food, macaroni. And when I pass those, so when I pass the color first, it gets plugged in by the function into the first slot, which it also calls color. And then when I pass in food, it gets plugged into the second slot, which the function also calls food. But then this is kind of off-putting for people. When I call the function with food first, it actually gets plugged into the color slot when it arrives at the function. So the computer has no way of figuring out by the data or by the names of the variables which is which. It has to be that the color, that the type and the order match what the function is expecting. So if I tell it food first followed by color, what the function's going to see is, well, whatever you gave me first is the color. Even though, oops, I put it food, but the function doesn't care. That's the color. The second thing I give it is the food. So if I reverse it when I call it, too bad. Notice I got macaroni red when I did that. So this is something to practice with. What I call the data, the names I use to refer to the variables in main don't have to match what they are named by the function. The function is going to take the stuff you give it in the order that you give it, and it's going to plug it in its order list. So whatever you pass to this function first becomes the color as far as the function is concerned. And whatever you pass in second is the food as far as the function is concerned. And the computer has no way of catching you making a mistake like that. You have to catch your mistakes by running the program, checking the output, and then kind of comparing, okay, I called it, why did I get macaroni red when I gave it a food and a color? And then, so food first, color second, and then I discover, oh crud. Whatever I give it first, the function is going to make the color, and whenever I give it second, the function is going to make the food. For my output, all of the funcs are on the same line. Oh, okay, so the Dan bar, you're probably missing the new line characters. So good question. So in chat, the Dan bar says, why are they all running across on one line? So you probably left the new line character out. And I'm glad you brought that up because that's an easy thing to overlook until you run it and you're like, oh, heck, what happened? So check yourself on those new line characters and make sure you get them in there. Sometimes you're going to want more than one too as well. So it can depend if you want two or just the one. Okay, so that's a whole lot of Mad Libs. Okay, good. So the Dan bar was able to fix it by finding where a new line was overlooked. All right, I don't know if hopefully that helps some, but it does, I know, take a lot of practice to internalize these concepts. So this is going back to that idea I was telling you that you are accustomed to looking at this screen and thinking of it as all one thing that is all kind of interacting. It's just kind of all magically mixes together and that's all good. But as soon as you start writing functions, you have created individual and separated units that you now have to do the work of making them talk to each other correctly. And by talk to each other, I mean you have to call them correctly. So greet is easy to call correctly because there are no parameters, so I don't have to worry about the kind of information I give it or that I get the information in the order that the function expects. But when I start using my Mad Libs function, now I do have to start paying attention because the order that the kind of information and the order that I provide it does have an effect on what happens when the Mad Libs function runs. Whatever comes in first in that list, the function is going to treat as the color. And whatever comes in second, the function is going to treat as the food. Even if the names match, that's not good enough. The order has to be what the function expects, which is color first, food second. Has to be. Go cannot help you fix that. You have to detect those errors by running your code and then fix them. So let's get rid of the yucky ones. So slow bicycle worked, but And in fact, when it prints out, um, it doesn't not make sense. So, but if we were to say, you know what, I was going to say enjoy eating your, but enjoy eating your slow bicycle is not completely unfunny. So I'll leave that. But anyway, hopefully you get the point. Your intentions toward the function don't matter at all. The function has rules and you have to follow them, or the function either won't work or it will do things that you didn't want it to do. So this function has to get its color first, has to get its food second. Let's do another one with parameters on it. I will do another Mad Libs. No, we won't. I'll call it donuts. And in this case, I will say num donuts, which will be an integer, and donut kind, which will be a string, and then a block. So as I am implementing the function, I am kind of setting forth the rules that I will later have to follow when I use this function. So I already know when I invoke this function later, it's going to need two things in its list. It's going to have an integer, and it's going to have a string, and they're going to have to be in that order. So the integer comes first, the string comes second, and if I don't do it in that order, it won't work. And I'll just do something simple like, so I ate this many of this kind of donuts, possibly just one, today. New line character. And then I'll plug in num donuts. That kind of variable, num donuts, is a pretty common shortening for number of something, which everyone will recognize. And in fact, I bet you guys immediately thought it's for the number of donuts. So that's one way that sometimes we shorten variables. When we would otherwise spell out the word number, which sometimes I will still do, but in this case, I thought it's pretty clear that I'm talking about a number of donuts. And then I will plug in second the donut kind. So there's the function. I haven't called it yet, but I am sort of registering the fact that when I do call it, I'm going to have to give it an integer and a kind. An integer for the number of donuts and a string for the kind of donut. So let's try it out. Donuts. So I will say an integer first, and then the kind of donut, I'll just say glazed. And let's run it and see what it does. Oh shoot, it's going to ask me this blue hamburger. I don't know. I ate 3 glazed, possibly less than that, donuts today. All right, so that worked. What happens if I switch the order around? Put the string first. I get an error. So these take some practice to understand how to read. But on line 36, it says I cannot use glazed, which is a string, which is what that means. So you can't use glazed, which is a string, in a place where an integer is supposed to be. That's right, because num donuts comes first. And I also says I can't use 3, which is an integer, where a string should be. That's right, donut kind is a string. So Go will catch you out in terms of the type of data and the ordering of the type of data. It won't catch you out if you do something silly like 100 shoes. It will catch me for the type of the data and the number of elements, but it's not going to do anything. I'm going to get rid of those in a second. It's not going to do anything to force the program to make some sense out of this silly thing that I just did. So, I'm going to comment. Nope. No. Comment that out. Comment this one out. In fact, I'm going to comment all of this section because I don't want to be stopped anymore waiting for the Mad Libs to run and ask me for my favorite color. Okay, so there's donuts, 3 glazed. Of course, you can also do variables. The names don't have to match. X is a terrible name for a variable, but let's just say count, which is an integer, and let's make it be 12. And then var donut, which is a string. Let's make it be chocolate filled, I guess. The integer part comes first. The string part comes second. And now I'm purposely doing this to get your mind thinking about it. I called the first thing count down here, and I called the second thing donut. Go doesn't care about that. What Go cares about is this an integer and is this a string? And then what Go's going to do with that is it's going to pass those values along and plug them in to those slots in the function. So the count, which is 12, comes first. Donut, which is chocolate filled, comes second. So 12 chocolate filled. So if I go to donuts, on the receiving end of this function call, the function itself is actually using the label num donuts for that number, which I'm calling count down below. This really messes people up at first when they realize this can work this way. So for me, the trick was to begin to imagine that the function donuts and the function main are completely separate units. They have their own variables. They have their own labels that they use for variables. They can talk to each other. Part of the way they can talk to each other is that main can pass information to the function, but main can't dictate what labels the function applies to that stuff. So here, main is passing count and donut in that order, count followed by donut, but it cannot dictate to the function how it's going to label that number and that string. So the function labels the incoming integer, which we know to be the value 12, as num donuts, and then uses it with that label accordingly. And it labels the second thing coming in. Doesn't matter what main calls it. What the function calls the second thing is donut kind, and then it uses donut kind in its output. So how does that work? It's simply a matter of the calling function sends information. The receiving function labels that information, num donuts, donut kind, and then uses its own labels for the incoming information. At least that's how one way that I would explain it to myself. That's a tough one though. So that's another one of those to be patient with. The way main labels those variables, count and donut, has no effect on the way the function labels those things. It's the order and the kind of thing that it is. So that's the way to begin thinking of it is I have to send an integer and a string. I have decided to call the integer count and the string donut. All right, now we're off. So an integer and a string, I'm not even going to worry about main anymore. It's down on the screen. So I'm going to switch my focus to this function. I don't care what main does. What this function does is it accepts first an integer, which it will label num donuts. Second, it will accept a string, which it will label donut kind, and then use those labels to use that data or that information for itself. They don't have to match. And they have nothing to do with each other after the moment when they're passed. So once they're passed, you just sort of have to think that what Go's actually going to do is just grab those two values and send them up to the function, which will relabel them. Okay, there's a question in chat. So the variables are relabeled as I'm describing it at the moment that the function is called, and yes. So more or less, that's the way I would, at least that's one way to think of it, is that the moment I call this function donuts and pass this data along, they're going to get relabeled by the function and used with the function's own labels on it. They can match, but when they match, it doesn't actually matter. The function doesn't care what main calls that data. It's going to use its own labels on that data either way. So yeah, that's a weird one, isn't it? Okay, now to the weirdest thing, the most difficult, at least in my opinion, concept. So with practice, you will very soon, with practice, get accustomed to passing data to functions, and then the functions will execute and you will be happy. I think of that as a one-way communication. You call this function donuts, something happens, and that's it. There's nothing about calling this function donuts that affects what's going on in main at all. The function is going to execute. It's going to print something out, but that it prints something out has no effect on main. There's no new information here. Just something goes out to the screen. So you have to sort of picture that a print statement is the program talking to the human at the screen. It's not the program talking to itself. So this print statement just goes out to the screen, and that's the end of it. So this is more or less main saying, hey, will you print something for me? There's not even sort of any indication that the function did in fact print anything. Watch. What happens if I don't even print anything? Well, just nothing is printed. And main, who was hoping for something to be printed, has no way of knowing what happened. Now, this is a hard one. But what I'm trying to get you to think of here is the idea that print statements aren't different parts of a program communicating with each other. They are different parts of a program communicating with the human at the screen. They have nothing to do with the computer communicating between parts of itself, the program. So these parameters are the computer, two different parts of a program communicating with each other. Because when this function main calls the donuts function, it is communicating information to that function that the function can then use to do something with. So this is, passing parameters is kind of like a one-way communication. Hey, here's some data. Do whatever it is that you do. Hey, here's some other data. Do whatever it is that you do. What it does is it shows something to the human on the screen. What it doesn't do, though, is answer back. So that brings us to the sort of the most challenging thing about functions, because it's just a difficult concept. So right now, this function, I'm going to leave it that way. It doesn't do anything to communicate back to main. Main just says, hey, take this data and whatever happens, happens. So what we want to do now is we want to add the ability to have functions have bidirectional communications, meaning I can call a function, send it data, and it can actually send data back that I could then use somewhere else in the program. So let's set up a scenario where we do that. Let me get rid of the donuts part, so we don't have to see any of that. I'll leave the greeting. Okay, so here we go. What do I want? Okay, let's do this. So let's say that we want to write a function. Oh, wait, we don't have logic yet. I shouldn't do that, should I? Without logic, this is less entertaining. That's okay. We'll deal with it. So let's just do this. So we'll say secret number. And now I'm adding a new component. So I'm creating a new function. I'm naming it secret number. It's going to have no parameters in it. And then it has this new element after the parameter list that says integer. So if you see something after the parameter list but before the block opens, that's called a return type. This function has one. It has a return and its type is int. So what this means is when I call this function can actually answer back to the code that called it. Let's just start with that. So we'll make the return, the secret number be 42. And then notice there's a new element here, which is a return statement. And what this return statement does is it allows this function, secret number, to actually send information back to the location that called it. So let's see what that looks like. So there's the definition of it. So now let's go call it. So we start just by the normal call. This is a function called secret number. It takes no parameters, but it actually returns data to me. So when I call this function, I'm going to get an answer back. And that's what the code I'm about to write does. So knowing that this function answers me, how do I know that? Because it tells me it answers me with an integer. All right, so let's deal with that. We are going to create an integer, and we are going to use it to capture the answer we get back from that function. Notice, by the way, that I created an integer variable. The reason I did that is because I know that the return, the answer I get back, will be an integer, so I'm going to capture that into a variable. So this is me saying, hey, secret number, and secret number says, hey, I'm going to return a number to you. You better capture it if you want to use it. So now main actually has data that secret number function produced. So now we have this kind of bi-directional communication. Hey, secret number, do stuff. Hey, main, here's my answer. And let's print it out. Where we're going to get an answer from the function, which we capture in a variable that matches what the function tells me it answers with. So this function is telling me I answer with integer. The fancy word for that is it has a return. And the reason why we say it has a return is because you actually use the word return when you want a function to answer. And by answer, I mean send data back to whoever called it. We do this all the time, by the way, in the human world. All the time. We ask someone for something, we might supply them with information and they give us an answer. So if I were to go to the donut store and I were to ask the donut person for 12 donuts, they would return to me the 12 donuts. So that's what this function is doing is, hey, I need a secret number and I am receiving back and capturing that secret number. And then from main, I can turn around and print it. So there's the answer I got from the function, which was 42. This one is the most difficult concept, so be patient with it. So functions can actually answer back. Now, why would we bother to do such a thing? Well, you'll see that in short order. One reason is because then it's easy to write tests to see if our functions are working properly. But it also is just, you'll discover pretty quickly that you can't write real software without functions that have these features on them. So you need to have functions that can accept parameters, and you need to have functions that can return values that can then be used elsewhere. So let's write another function. In fact, let's use the secret number to run the donuts. So I'm actually going to use the answer I got back from the secret number in combination with glazed donuts to produce an answer. So I can actually receive the answer and then turn around and send that answer as input data, as a parameter, to a different function entirely. So I don't know if you can see it very well here because you're new to this, but what I'm doing here in main is I am sort of connecting these two separate functions in code. So I want secret number and donuts to work together. So the way I do that is I call secret number and I capture its return, its answer, and then I turn around and I call the donuts function with the answer I got from that secret number function. And I can do that for the donut part if I wanted to as well. Func secret donut flavor. This one's going to return a string. I don't know. We'll do blueberry. So here's the function. It returns something, which will be a string, and then you'll notice that the way it does that is actually using the word return in conjunction with a string because that's what its answer is supposed to be. Notice for secret number, it returns an int, and it uses the word return to achieve that effect, and what it returns is in fact an integer. There's a lot of moving parts, I know. But let's improve this. I don't need to know that answer. So let's just put this together. Hopefully I named, was that the name? Secret donut flavor? Yep. So what I'm doing in main now is I'm coordinating the efforts of these three functions. So I'm going to use the secret number function to get a number, the secret flavor function to get a flavor, and then the donuts function to display the information that I managed to collect from those other two functions. So to me, this helps a lot to understand why we have return values. It allows us to use a series of functions and coordinate them so that we can take the information that is returned to us from some number of functions and actually use that information to drive even other functions. So the secret number, the secret flavor will get plugged in ultimately. So I ate 42 blueberry donuts today. And it's that ability to talk back and forth between functions and then communicate, sort of arrange that all of this information is shared between these functions is why return values are so cool. Okay, so there's that. We can also do this. We can actually return multiple things from a function. So you'll notice a difference here is that there's a list of things that are going to be returned. And the list is collected into parentheses, which the Golang will force you to do. So what I'm saying here is secret combo will return a list containing an integer followed by a string. And so we will return an integer followed by a string. So the secret combo, the integer part is a 1 and the string part is a plain. So now we can actually write a function that returns both pieces of information at once, and let's try it out. I'll gather those together. Okay, so let's do the same thing, but let's use the secret combo this time. So secret combo, and I know what it's going to return to me is a list that is first an integer, second a string. So I'm going to capture first an integer. I'll just reuse this variable. Second, a string. And then I'm getting both pieces of information in one fell swoop. Doesn't always work out that it's convenient to do return more than one thing, but sometimes it works out and it can be handy to do so. So the secret combo is returning an int. And so the Dan bar asked about the function that's called relabeling things. What's happening here, of course, is that I'm relabeling things on the receiving end. So secret combo is returning two pieces of information, and I am relabeling them as number and flavor. And then I can fire off the donuts function again, which should say one plain donut. So there's my one plain donut. And again, what I'm using the return values for is to coordinate the activities of more than one function. So I can capture the answers, the returns I get from secret combo, and then coordinate that information, coordinate the donuts function with the secret combo function by passing the data along. So I get the data from this function, and then I pass it along to this function, and thereby I've coordinated the activities of the two functions to produce this result. I ate one plain donut today. Sorry, I've got a whistle on my nose here. So these are hard ones. Takes some time to get comfortable with it. So don't feel stressed. Don't feel rushed. We'll see plenty of examples. I'll give you. I will try to give you plenty of hints about how to do the labs as we get going. So part one is that stuff. Now let's add part two, and then we'll do the lab that does both parts at once also. So now let's switch gears a little bit and talk about unit testing. So for functions that don't return values, they are very difficult to test. So it's very difficult to know the greet function is working unless I run the program. So the whole idea of unit testing is that I want to have some way of automating an evaluation of the code so that I don't have to sit there and run the program and interact with it to see if it works. I want to automate as much of the process of evaluating my code as possible. But it turns out that evaluating functions that don't return values is very difficult without running the program. So this greet function would be difficult to evaluate in an automated fashion with a unit test. Mad Libs also will be difficult to evaluate with an automated unit test because it returns no data that can be checked. These two functions I would have to run the program and examine their output to see if they're working correctly. Same goes for donuts. It doesn't return anything, which means that really the best way to evaluate it is to put it in a program, call it, and examine its output to check and see if it looks correct. But these three functions I can automate the testing of because they return values. And a function that returns values makes it relatively easy to automate a test of, because I can execute the function, and then in my separate automated test I can simply check to see the answer I got back, and the answer better be the one I was expecting or the test will fail. So I'm going to write one of these from scratch basically, but you will never have to write a unit test. I just want to show you how this works. So these three functions that answer back with a return, I can write automated tests for fairly easily. All right, so here's the process of writing an automated test in Go. I'm testing the code in main.go, so hopefully this is going to work. So I create a file called main_test.go. That's required in the Go language. If I'm going to test the code in main, the test itself has to be in main_test.go. It did it. So I hope you all have that experience and you won't need the extra instructions for I can't create this file. So for me, it worked. I just created a new file. I called it main_test.go and everybody's happy. So main_test is precisely and can be no different what the testing code has to be called for the code in main.go. So main_test will contain tests of the code in main.go. All right, so let's implement main_test.go. So we're still in the main package, but now we're going to be writing tests. To do that, I'm going to import testing. So this is kind of a built-in thing. There's some of it's going to look yucky. Don't worry tons about it. Because I'm always going to write your unit tests for you. I just want you to have a sense of how I make them, why I make them, how they work, and then how you will use them on your labs. So I'm writing a unit test right now from scratch in the Go language for the code in main. The unit test itself is called main_test.go because that's what it has to be called in Go. All right, so what is a unit test? It's a series of functions that test things. So for example, I can test the secret number function. So the testing function itself will be called test secret number. And then the nasty looking part, which this is simply a requirement of the Go unit testing code. I will always write these for you, but this is how I make them. So I am set up to have a function that actually tests the secret number function in the main.go file. So how do we test it? Well, first, we call the function and we capture its result. Now I'm going to start using the shortcut form of capturing the return values. And you're going to see that in my unit test that I'm using the := which is a shortcut for this. So if secret number returns an int, result will be an int. I could just as easily do this, and it would work just as well, but my style when I'm writing tests tends to be that I use the shortcut way of creating this result variable. So I'm going to capture the answer that I get from secret number, and then I'm going to define what I expect to get. And let's just say, for example, I'm expecting a 99. And you'll be able to understand this code even though we haven't written this kind of code yet. So I have a result that secret number answers me with. I have what I expect to get, which we know is wrong, but let's say I'm expecting a 99. And then I'll just say, does the result not match what was expected, which is what this code means. If the result I get does not match what was expected, then I'm going to print out an error message. And I will say expected this integer got this other integer instead. And then I will plug in what I expected and the result that I got. That is, for a while, as elaborate as my unit testing functions will be. So there's stuff in here I know that you don't recognize, although this error thing hopefully looks a lot like a printf because it is. So this whole chunk's job is to test this secret number to see if I'm getting the result that I expect. Now I'm saying that I expect a 99, but we know that's not true because I put a 42 in there. But let's just say that's what I wanted, and then I forgot and made it be a 42. So how do I now run the test? You go down here to the console. So I clicked in here, and I'm going to type go space test space star dot go. So that's go space test space star or asterisk dot go. There's instructions for this in the guides, by the way. And we'll review the lab before I quit, and you'll see the instructions linked there. So I am going to run this test. The test failed. I knew it was going to fail, but let's just see what the fail says here on the screen. So I failed the test secret number test. It says on line 12, I was expecting a 99 and I got a 42. I was expecting a 99, but secret number gave me a 42. Well, if this is what I was supposed to get, then my job is to go see what I did wrong in secret number. And I go here and I'm like, oh, crud. I'm answering 42, not 99. So I'm supposed to answer 99. I'm going to change that. Not run. Let's go back down here and go test star.go. This okay means everything worked. I believe that you can do go test star.go -v and get more verbose output. You can. So by adding space -v at the end, I actually see a full report of the test as it's running, as opposed to just the final result, which is everything's okay. So now it tells me which tests it runs, which tests it passes, and the final result, which is everything's okay. We're all good. All right, let's write one more, and then we'll switch gears and look at the lab. So let's test. Well, we'll just test all three real quick. So let's test secret donut flavor. So one thing you have to imagine is when I write the test first, and then I have you implement functions that pass the test. So usually how this works is we write the test with the results that we want from the functions, and then we write the functions that satisfy the conditions of the test. That's what test-driven development is. The tests drive the development. The way you might imagine this being used is that a senior engineer on a team might write the tests, and then the junior engineers would go implement code and then run their code against the test that the engineer wrote. And when the junior developers have done their jobs right, they pass the senior engineer's test. That's kind of the idea. Let's test secret flavor, I think I called it. So we'll grab a result from the secret, I think it was called flavor. Let me check. Secret donut flavor. So now what I'm going to do is I'm going to play the role of the senior engineer. And what I'm going to do in my test is kind of through my test, I'll be communicating to my junior engineers that the secret donut flavor should be plain donut. So I'm writing this test as a way of communicating to my engineers, when I call your secret donut flavor function, I expect to get the answer of plain back. And then I'll check. If the result is not equal to what I expected, then I'm going to emit an error. So I expected, these are strings now. So what I expected and the result that I got. And I'm using the shortcut for creating these variables to get you used to it. So there's another one. I'm going to go run it as a test. By the way, if you're taking notes out there, if you get a cluttered console screen down here at the bottom, you can type clear and hit enter, and it clears the screen, which I like to do. So now let's run the test. Let's do -v and see all of the tests, because I know I'm passing some, so I can see that. Um, so the test is being built and run here. Okay, the good news is that when it runs the secret number test, I'm still passing that. But when it runs the secret donut flavor test, I fail. And it tells me how I failed. It was expecting plain, but got blueberry. So the result was blueberry when it was supposed to be plain. So the junior engineers now go to the secret donut flavor function and they satisfy the test. It wants plain as the secret flavor. So I update the code and then I rerun the test. I'll do it in verbose mode so I can see both my passing. It's hung. Yeah, it's hung. I'm gonna refresh and hopefully don't lose anything. Might be a bummer. Yay. So let's see if my change. Okay, yeah, so plain change, so I can rerun my test. Go test, start out, go verbose mode so I can see both my passing and my failing tests. It runs the secret number. I pass that. It runs the secret donut flavor. I pass that. And if I were to finish this out, which I'm going to switch to the lab, but if I were to finish this out, then I would also test the secret combo with my desired outcomes and then adjust the secret combo function to satisfy the requirements of the test. Okay, so let's, I'll put a link to this, by the way. Let me just set it aside real quick. I'll link this. Did I make it private? No, it's public. So I will simply link this whole Repl on our lecture page. So you can just come in here and see the whole Repl and everything I did in it. So let's set up a new Repl and just go explore the lab real quick before I call it a night. Go, please. This is lab 6. I'm not going to do anything, so no reason why I can't be. I have the private option because I pay for it, which lets me do my own implementations without kind of exposing to the world my solutions. Okay, so how is this going to work? Well, let's go look at the lab and see how this is going to work. Okay, so remember this having trouble. I didn't have this problem. I hope you don't, but if you find that for some reason main_test.go is just not for some reason being created, and this has happened to people in the past, then I have this extra set of instructions to get around that problem. So you don't need to worry about the having trouble creating main_test.go unless you have that trouble, and then the lab has these instructions. So we need 2 files. We need main.go, so let me go grab that and plug it into main.go in my Repl. Seems okay. Now I'm going to make a main_test.go. It let me do it. So now I will go to the lab and I will grab that, which it's labeled as a new step, by the way. So just read carefully. So let's go get the test. Plug that into main_test.go. It's already been written, so I have nothing to do with the test other than put it in here and run it. If I run it now, what happens? every one of them fails. So what I'm going for is that the last thing here, that fail never shows up, and then I get an okay at the end. Every one of them fails. Well, that's to be expected because this is a lab and it has been left empty. So you'll notice some changes. I'm going to do one easy one and maybe one harder one. So, and hopefully there's some people in chat still who can help me with the easy one. And by that, I mean I'm going to do it wrong. So I'm going to focus in on just this one function. So the way to do this is to go find the test or test for hello world, or I can look at the output down here, find where hello world is being tested. There it is. And then see, oh, so it expected the message to be hello world exclamation point, and it got nothing. Well, let's go look at it. There's actually some documentation here. So returns the message hello world, takes no parameters, return value, which means that this return statement needs to be there. And I can also tell that's the case because this function answers with a string or returns a string. So a string containing hello world. Okay. Hello. I'm going to go down to the bottom. I'm going to clear, and then I'm going to rerun the test. Test hello world. Expected message to be hello world. Got hello. Well, crud. Okay. So I'll make that change. I will go down here. I will clear, and I will rerun the test. Still got a problem. There's no pass here. I fail hello world. So expected message to be... So I'll highlight that and see if anyone in chat wants to venture a solution. So I still got something. Thank you. The Dan bar was right on top of that. In fact, you probably were ahead of me in asking the question. Nice one, Karina. So you guys, the Dan bar and Karina, are exactly right. It expects hello world to have an exclamation point on the end of it. Or is that what it's called? Yeah. But I didn't put one. Okay. So, but did you notice how I can just kind of, I can try something, run the test, fail, try something else, run the test, fail, and then eventually I'm going to get down to where I make the change I hope allows me to pass that part of the test. So I'm going to run the test again. Go test, go. I'm going to run it in verbose mode. I am now passing the hello world part of the test. Now I can move on to the next test, and then the next test, and so on. So that's part of what this lab wants. The other part that this lab wants, if you scroll down to main, and this is in the instructions, if you scroll down to main, it's going to ask you to do some other things. So it turns out that you can have a test and a program in the same space. So I can still click run, and I can still run a program. It doesn't do anything right now, but it will once I've added these steps. So your challenge this week is to develop the program and pass all the tests. You can do these in whatever order you want to. If it were me, I would probably try to pass the tests first, and then I would come down here and I would complete the program. But it's completely up to you. You can do a little bit of the test and a little bit of the program. You can do all the program followed by the tests. To me, if there's a test present, I'm going to try to solve the unit test first, and then I will implement the program that goes alongside it. So you can have both, and we do. We have a main with a program in it, and we also have a main_test with a test in it. We can click run for the program, and then we come down to the console to run the tests. Hopefully that all makes sense. What else we got? I'll take the easy one away. That's uncool to me, isn't it? No, let's do this one. Or birth year. I'll give you part of this one. So we know we're not passing greet user, which I will go back into testing mode. So greet user. So greet user with no name should return hello space exclamation point. Well, let's just try hello again. No, I don't want to run the program. Stop. I want to run the test. Clear, go test, go -v. I want to run the test, and I want to see how I'm getting along with the test. Still passing hello world. That's happy news. I'm still failing a greeting, and I'm also failing a greet with a name. So he's saying hello, gophers got hello. I'm going to have to figure out this gophers thing here. Anyway, so with nothing in here, it expects hello space exclamation point. But something seems wrong about that because it's telling me hello person. So hello person. Darn it, not run. Test. No. so not hello person. So what it wants me to do is it wants me to plug in this person string where this person is. So how do you do that in this context? I'm going to go ahead and solve this one while we're sitting here. I have a few minutes. So if I wanted to print this, I would say format.printf hello string person. But printing something is not answering with that. It's just printing it so the human can see. So this is not right. But there's a trick. If you need this, instead of printing, you need it to be your answer or what you return from a function. You can actually just adapt it to that. So you can, I'm going to copy that. What you can do is you could say, I don't want to print it. I want to stringify it, which is what this S kind of does. I don't want this going to the screen. I don't want it printed. I want it stringed. So we can actually use the exact same approach, but we can use it in a context where I'm not supposed to print something. I'm supposed to string something. So I'm going to return not printing, but stringing it. And let's see if that helps with the tests. Clear, go, test, star.go. I'll go verbose mode so I can see my passes. And I am now passing both of these, the greet user without a name, the greet user with a name. If I want to know what's going on in the test side, I'm certainly allowed to go look. So let's just go look at the tests. We had, here's greet user no name. So what is it doing? Oh, it's calling greet user with nothing. And then saying it's expecting hello and then a gap. And then with a name, it's actually calling greet user with the word gophers. Oh, that's why it was expecting gophers to be plugged in, because the function should be plugging it in. In the case of greet user with nothing, the function should be plugging in nothing but the space that would have been there between an actual name and nothing. So you can always come in here and inspect the tests directly if you want to get a sense of what's supposed to be happening. So estimate age 0, which would happen if I estimated the age for a person born in 2022. I should get back that they haven't had a birthday yet. And then the test would tell me if those don't match. And then you can see that's really the only test of estimate age. And then there's a few more tests on the averages. So that is most of what I intend to show you. So you can look at the test. You can inspect the output of running the test. I like it in verbose mode because I get to see what I'm passing and also what I'm failing. I'm accidentally, by the way, passing one of the tests even though I never implemented it. I also have the ability probably now. Yep. So I'm supposed to actually use the estimate age function in the program side, not the test side. Okay, so there's a fair amount of moving parts here this week. Your job is to, I've already done 2 of the functions, so your job is to finish the other 2. And then pass the test, and then finish the program, which has a few steps in it. All of these steps you are at this point, or should be well familiar with. Okay, that's where I'm going to stop. That's a lot. I'm going to go ahead and put this in. I'll upload this to the lecture notes. So the partial solution I'm going to post also onto the lecture page. So there will be a link to the samples, and then there will be the actual code for the partial solution for the lab on the lecture page. And of course, you can watch all the things that I did in video. Okay, so good job in chat. Thank you. It takes courage to venture an answer when you may or may not get it wrong. But it's wonderful when you do it right or wrong because it gives us something to discuss. So thank you for that. That's very much appreciated. Yeah, I think that's about it. So look on the lecture page. The video will get processed and uploaded sometime in the next 24 hours, but pretty quickly here I'll post the sample code and the partial solution to the lab stuff. Don't forget you have Piazza. You can ask questions in Piazza, give your classmates a chance to help you, and also be helped by you, your questions and everybody's answers. Canvas inbox, office hours are all available. So you're going to be returning things and applying a unit test in addition to completing the implementation of this program that the unit test is built to go alongside of. So good luck on it. It looks scary when you look at it as a glance, but when you get into these functions, you'll find that the amount of code that you need to write is actually fairly small. So if you're writing lots and lots of code, you're probably doing something wrong. This is meant to be continuing our exploration of functions and now adding the ability to automate the testing of them. All right, with that, I'm going to say good afternoon or good evening. Have a great week. Don't forget the channels that you have to communicate with me and your classmates, and otherwise I will look forward to seeing you all again on Tuesday afternoon next week. So have a great week. Thanks for being here if you could. Thanks for watching later if you're watching. Take care.